Hey guys, and welcome back to UniCodev. Yesterday, the 24th of February, Google hosted a competition about coding. You had 4 hours to develop an algorithm to solve a certain problem. Now, I'm gonna describe the statement in just a second and also talk more about our thought process, but before that, I actually wanted to say why am I doing this video. Well, the reason I'm doing this video is because this competition happens every year, so if you guys want to participate or even team up with me, or, we could even do different teams in our, UniCodev hub and, compete against each other and see who gets more points. We could do that next year, because this happens every single year. There are actually multiple competitions that Google is doing similar to this. So if you are interested in coding, and especially coding competition, the links are gonna be in the description to try this out. And maybe we can do something cooler on the channel, to make this stuff more interactive. Anyway, another reason I wanted to do this video is because, doing these kind of code jams helps you approach difficult problems. You have a really difficult statement, you have really limited time to figure out. You have to optimize not only your code, but also, your time. And you have to cut corners and try to, find a possible solution as soon as possible to get the most points. So I'm gonna leave the problem in the description. I'm not gonna read it all, but I'm gonna summarize it. Basically, you have a list of projects that require certain roles. So you have a list of projects, at example, logging, that requires some experience in C++, okay? It requires a level 3 of experience in C++. So the only person that can complete this certain task is whoever has this required level of experience. And this task only needs one person to be completed, okay? Now we have this other task, which is doing a web server, okay? It needs 2 people to be completed, and these 2 people, one of them has to be fluent in HTML, a level of 3, and another one has to be pretty good in C++, a level of 2. We also have a list of people and all of the things they are good about. So, at example, we have Anna right here, which is pretty skilled in C++. We also have Bob, which is really good in HTML, but also really good in CSS. So this guy is amazing. And then we also have Maria, which is good in Python. So this is the information we get, and what we want to develop is an algorithm that assigns each people their project. So as you can see, this is the output, and as you can see, on the web server project we assigned Bob and Anna, on the login project we assigned Anna, and on the web chat we assigned Maria and Bob. Now, unfortunately, it's not this simple though, because people can only work on one project at a time, and actually projects require some time to be completed. So as you can see, the web server project requires 7 days to be completed, and once it's completed it's gonna give us a score of 10. So as you can see in the output file, these 2 people will be working for 7 days on the web server project, and Anna is gonna be busy working on this project. Then after 7 days, Anna is finally gonna be free and is gonna be able to work on the login project. While all of this is happening, web chat project is gonna start right away because Maria and Bob are gonna be working on it. Now you get points for every project completed based on the score, but also this number right here matters a lot. And honestly, it's the worst thing about this entire statement, because you are timed. If you don't complete the project in this amount of time, you're gonna start losing points. So if I complete this project right here in 8 days instead of 7, instead of getting 10 points, I'm gonna get 9 points. And so on and so forth, until the points turn to 0. So I'm also really limited by the time I have to complete these projects. If I take too long, I'm not gonna get any points at all. Also, naturally, to complete a project, you have to assign people that are capable to completing the project. So, for example, in the web server project, I cannot assign, let's see, Maria, because she doesn't have experience neither in HTML nor in C++, but I can assign her in the web chat project because she has experience in Python. And this is still not the entire problem statement, there is something more. Basically, if you assign a person to the project, and that project is the exact level of experience they are at, so in the example of Maria, she is level 3 in Python, and the project requires level 3 in Python, once they complete the project, they are gonna level up, so they're gonna become level 4. So now they will be able to do multiple projects, or more projects, that require level 4 in Python. And also there is another concept which is called mentoring, which basically means if you don't have the skills required to do a certain project, but you are one level below those skills, you can still do that project if someone else in the team has the required skills, so it can mentor you. Now, this is a lot of condition and it's really complicated. If you wanna know, specifically what I'm talking about, before continue watching, you can read the problem statement in the description, but you don't need to watch this, you don't need to read this all to understand, the video. So don't worry if you didn't get everything. But this is basically the summary of the problem we had to try and beat in 4 hours. So our objective is basically taking this input file and transforming it into this output file that basically tells what people must be assigned to what projects, and also in what order. So how do you approach a problem like this? The first thing that you have to do, naturally, is parse all of the input you get. This is a lot of information we get. As you can see, this is the input file, and this is just the example input. If you go to a data that is more, difficult, like this data set, we are gonna get much more info. As you can see, this is all the info we get. This is a lot of data, so we need to parse it correctly. So first of all, we had set up some code already that was able to parse data files, text files, because we know that that is always gonna come useful. We did this last year, so naturally we came prepared this time. Thanks to Cacafier, we have this code that is basically be able to parse some input. I'm gonna show it right now. So as you can see, you can load stuff from a file, and you can also save a file, which is basically what we wanna do naturally, because we want to read, a certain text file and we wanna save it. So the first thing to say is come prepared. You know that you're gonna receive text file inputs, so already have a way to serialize them. Also, we used C# as a coding language. You can use any language that you want for this challenge, because you actually don't have to run the code on their machine, but all you have to do is upload the text output file. Now, we basically also had a class that would take all of the different input files and would run them asynchronously, meaning that it would run each dataset at the same time. And this saved quite a lot of time, especially when we were, submitting these and seeing what our score was, because we only have 4 hours of time, and plus, we cannot waste time, running the script for all of the different datasets. So having something that, runs it asynchronously is really helpful. So it's gonna take the input file, it's gonna load it, it's gonna run our magic algorithm with the input file, and it's gonna return the output file and save it. Now you may say, Nico, what is all of this code right here? I'm gonna explain it in just a moment. We only had 4 hours, so the code base became really messy really quick. Anyway, now that the part around the algorithm is explained, let's explain the actual algorithm and our actual idea to beat this impossible challenge. And when I say impossible, I'm not kidding. Meaning that if you watched the live stream right after the event ended, the people at Google actually said, if you're able to beat this optimally, you will also be able to win like a Nobel Prize for beating other problems optimally. So this means that there was no way to build an algorithm that, created the best score. Definitely there was no way on doing it in 4 hours, so you had to try and get the best you could get, basically. Have an idea and try to write it down in as fast as possible, basically. Now, naturally, as an input, we have a list of strings, which are basically the different line of text. Here, right here, all of these lines of text. So naturally, we had to serialize all of this data, which, it's already a challenge in itself, but it's being done by this input function right here. So we have the number total of contributors, the number total of projects, and we also have a list of contributors and a list of projects. Now, we decided to make it a key value pair, just so we could get the information we needed easily. And right here, we're just deserializing all of the data. So at the beginning, we are seeing all of the contributors and all of their skills, all of their levels, and we're basically writing down all of that stuff. So we know that there are, in this case, an example, 800 contributors. The next lines are gonna be the contributor data. So for 800 times, I'm gonna repeat this code. I'm basically gonna get the data on the line, which is gonna be like the contributor name and their skills, and I'm gonna parse it. So I'm gonna go to the next line, I'm gonna get their skills, and I'm gonna repeat this for the number of skills that they have, because they can have more than one skill. For example, I think right here they all have one skill, but I mean, this is just a special case. And then when I'm done, I'm gonna add the contributors in, and then rinse and repeat for 800 times. And then the same thing for the projects. So there are 1000 projects. I'm gonna get the project ID and all of that stuff. And also there is more information about the project, how much time it takes, the score, what's the deadline basically, and also the roles required. And then for every single role required, we add a new line and we get actually the required role. So after all of this is done, we end up with this sort of input file. We have a list of contributors and a list of projects. The contributors basically have this information. They have their ID, their skills, which is basically a hash map. And you don't worry about this. This is something I added later to get more information, but this is not in the input. Instead, the projects have different information. They have an ID, they have, as I said before, the duration, the deadline, the score, and also the same hash map with the roles required to complete this project. Okay, so now that we parsed all of the data and we have it in this input object, let's actually look at the algorithm. Now, what I want to do is actually I want to go to an old version of this algorithm because this one is really convoluted. And at the beginning, we had a really simple idea of something to do, so I want to go to that. Okay, this is the first iteration of the algorithm that we created. Now, don't worry about the errors, it's because, I actually changed stuff in other files too. I just brought back the old algorithm from GitHub. Now, basically, our initial idea was get all of the contributors and just assign them to a project. Now, the first thing that we wanted to do was order the projects by best before, which is basically the deadline. So we wanted the projects that, had the tighter deadline to come first, okay? And then for every single project, we had to find people to include in the project. So we would iterate for every single role that is needed to, actually run that project, do that assignment. And then for every single role, we will try to find a viable contributor. So we will go to every single contributor and we're gonna find one that isn't already working because a person cannot work on 2 projects at the same time. So we're gonna find one that is not working and also that has the required skills. Now this code is really convoluted, but basically what it's saying is we wanna find a contributor that has, a matching skill. So the key of the role is also matching with the skill that they have, and also the value of their skill is equal or higher than the level required for the role. So once we find that contributor, we add it to a list, and also we make sure to know that it is working. Now, if at any point we don't find a contributor, so this contributor is null, then the project is not going to get included because naturally we don't have enough contributors for this project. So then we're going to stop iterating for each role, and if we added any contributors, we're just going to dismiss them. We're going to say, okay, we don't need them anymore because the project never started, unfortunately. If instead the project started, we are going to add it to the output of the projects. And there we go, this is our output. And then finally we have a function that parses the output. So we have a list of assignments, basically, and we're just gonna add them in a text file, and it's gonna return us our output. Now, I don't know if I can actually run this code. Okay, so now I was able to fix the exceptions with the code, so now we're able to run it. And as you can see, I have right here, let me go to my Thunder. Okay, I have right here all of the input files and also the outputs. I don't want the outputs, I just want the input files. Okay, there we go. And we're gonna run our algorithm that is gonna do exactly what I described, and now it's gonna generate our output files, hopefully really quickly. Okay, there we go, it's almost done. It didn't do all of them. Oh, did it do all of them? Okay, no, now it's done. Okay, so now that we have our output files, we can actually submit them to the machine, and the beauty of this is, even if the competition is over, we can still submit our outputs. So I'm gonna submit the output E, just for the sake of example. Okay, and now that we submitted our attempt, we're gonna get the result. And now, naturally, since this algorithm is really basic, we're not gonna get a good result. I mean, it might be good, it depends, but it's not the best result that we got out of the entire competition. So now it's getting, it's pending, and as you can see, we got 33,000 points. But there is a problem. And the problem is, we only assign people to each project once, and then once they are done, that's it. They're just finished. We are not taking advantage of the fact that after they are done working on one project, they could work on another one. And also they could level up. So we're not taking advantage of any of that stuff. We are just assigning them to any project, and then that's it, they are done. So this is a really simple algorithm that assigns people, but naturally they are not going to be done with a lot of projects. In fact, out of all of the projects which are like 10,000, we only got through 3% of them. So only 3% of the projects got us all of these points. So if we got 100% of the projects, we would have gotten 1,000,000 points. So you can see how this is really bad. Now, this attempt below is the same attempt, but with a more complicated algorithm that I'm gonna describe right now. And as you can see, instead of 30,000 points, we got 700,000 points, which is still not that impressive considering people got like 2,000,000 points on this. But you know, it's a little bit more reasonable. And as you can see, half of the projects managed to complete, even if only 35% of the project scored full points. Some of them received 0 points because they were done after the deadline. So we went from 3% of the points to 35% of the points, which is pretty impressive. I also love how it says the contributors were waiting for the new project on average 1,238 days. So like they had to wait 4 years in order to get a project. They were like, okay, I'm not gonna work for 4 years, I'm gonna still get paid. We got 700,000 points, but this is definitely not the best work environment to be in. I'm gonna actually explain the algorithm we ended up with, the more complicated one, which is actually not that more complicated, it's just doing the same operation, but iteratively. And honestly, I wanted to do many more optimizations, but only having 4 hours is really difficult. Already writing all of the parsing input and output code took us like over an hour. So we had very limited time and a lot of time pressure, so it was kinda hard. Okay, so this is the final algorithm. Now you may think that it's really different from the one before, like it's completely different, but actually what I did is, the algorithm we were doing before was good, but we need to add more stuff to it. I feel like that's an important thing that you do when you're time pressured. You don't have to have a lot of different ideas. I mean, we were in a team and any of us was doing different stuff, but we brainstormed about ideas. So yeah, it's good that we all approached the project in a different way, but individually, you have to have an idea, and then you have to build on top of it in order to succeed. So the code that I was doing before, the one that I described before, is exactly this one. So I put it into an individual function, and this function is called assign contributors to project. Now this function is gonna have as a parameter the day you're currently in, and I'm gonna explain this in just a second. The output it should write to, so it can update the output and add more assignments, just like it was doing before. But also it needs to know the contributors it can pick from, so the contributors that are available, and also the projects that are available, so the ones that are not being worked on or that are already done. Now this function is really complicated because it will also return a complex object as a result. Now we are giving as a parameter some contributors and some projects. After this function has run, I need to know which of these contributors are still available, which of these projects are still available, and which projects were assigned. So this is why I have this function right here, this object right here, that returns me exactly that information. And now, surprisingly, we didn't need to know the projects that were assigned, probably because we already know the ones that are not available anymore. So we actually don't need this variable right here. But when I coded this, I didn't know that I didn't need this, so I just tried to get as much information as possible. So this function is exactly the algorithm that I described before. It will just assign, people to projects wherever they are free. But now the interesting thing is when we are running this function. So now we are taking all of the projects and we are still ordering them by a certain criteria. This time though I changed the criteria. I don't know if this was actually for the better or worse, but I found better results with this function right here. Instead of only sorting by best before, we sorted by score divided by best before plus the duration. I don't know why, but this gave the best results, but naturally we didn't have a lot of time to test it, so this could have been, just a dud, and maybe it was better to just sort by the deadline, but I don't know about that. That's the problem with not having much time. But also right now there is a practice mode going on, so if you want you can still get more points by just, running this code and trying to mess around a little bit with it and its parameters and see if you can get more points. Anyways, once we ordered the projects, we are also gonna create 2 objects, the active contributors and the active projects, which at the beginning are just gonna be all of the contributors and all of the projects. Also, we're gonna have an integer that stores the number of days that have passed, so right now that is gonna be at 0. Now we're gonna have a while loop that repeats till the end of time. So it's gonna still always try to assign people to project whenever it can. Now don't worry about this piece of code, I'm gonna explain it in the end. But yeah, the first thing we're gonna do is run the algorithm we were running before once. So we're gonna take all of the projects and all of the contributors and we're gonna assign them to the project. Once we do that, we are gonna get a list of the still active contributors, so still the available ones, and the active projects, which are the available ones. So we're gonna update these two objects up here into here. Now, another change to note is that we are no longer checking if a certain person is working or not. We are actually using a different variable. So this before used to be a boolean, and we were just checking if a certain person was working or not. But I changed this into an integer. So basically, instead of knowing if a person is working or not, we know for how long they are working for. And this is gonna come useful in just a moment. So right here, instead of checking if a person is working or not, we're gonna check if the person is occupied on this day. So we're gonna check if the day variable is greater than the is occupied until parameter. And if that's the case, it means that the person is free to work. And when we assign them a job, their occupied until parameter is gonna turn into the current day plus how much time it takes to complete that project. So all of this makes sense, and the function is gonna work the same way as before. But now here is the interesting bit. Once we actually got the results, we are gonna have a list of assignments. Now we're gonna iterate over all of the assignments and we're gonna try to find if there are any that are not completed yet. So keep in mind these assignments were started right here, so this function started these assignments. They are basically the available projects in the result. Now if any of them are not completed, we are gonna find the project that has the minimum duration. So the one that will complete before all of the other ones. And basically we're gonna take this one and we're gonna mark it as done. And then we're gonna take our day counter, which was 0, and we're gonna add the project duration. So now we know that this project is done and it's been this X amount of days have passed. So now that this project is done, all of the people that were working on this project are now free. So we're gonna take these people and we're gonna add them again into the available contributors. And now don't worry about this code right now, but after all of this is done, we're just gonna repeat the entire loop again. So these people are now free, so we can assign them to new projects. And then we wait until one of the projects is completed and do the entire loop again. Now reading this code, there is some weird scenarios where, a project could be completed before this day counter, because maybe the project was started before. So the duration is not gonna match the day counter. There are a lot of problems with this code. It's probably not the best one, maybe not even the most optimized one, but it does its job. It gets us points. And honestly, in that amount of time, it's something I'm not proud of, but that worked out. But now this is not it, because this code ran and actually gave us quite a lot of points. But before finishing the competition, I was actually able to add in this other line of code. And this thing here basically talks about the leveling up. So if a person completes a project where they are the same skill level as the project, they're actually gonna level up. And this is what I'm describing right here. So for every contributor in the project that just got completed, we're gonna iterate over every single possible role, and we're gonna find the contributor for that specific role. We're gonna check if the level of the role is equal to their actual level of competence, and if that is the case, we're gonna level them up. So as you can see here, we're adding 1 to their skills. So this code helps because this certain contributor is gonna be able to do multiple projects or do more projects now that he leveled up. And this is it, this is literally all of the code. The problem is this code actually takes so long to run because, when you have, let's see, 10,000 projects, it actually has to iterate over every single project and then iterate over every single, assigned projects and do a bunch of recursive iterations. It actually takes such a long time to run because, it takes a really long time to finish assigning all of the projects. And naturally, we didn't have a long time. After I finished writing this algorithm, we only had 30 minutes left and we needed to drop a result. We couldn't just not submit anything. So this is why this line of code is here. So instead of parsing the output at the very end, it's gonna actually parse the output every single step of the way. So every single iteration, every single day, we could say, it's gonna parse a different output. And this partial callback here is the one that we defined at the beginning of the video, the one I told you not to worry about. And it's basically just saving the file at each step. So as you can see here, if we run this code, in the case of B and D, we actually get the result really fast because, they are really simple. but the E one that actually contains 10,000 projects is gonna take a while to give us results. So here you can see the output file, and you actually can see the projects being added in live time. So as you can see right now, it assigned 400 projects, and it's still going because people are getting freed up and getting more projects done. So it's cute how you can see the actual workflow in real time. So that's pretty cool. And then I just take this file, even if it's partial, and I just uploaded it in here after I waited 30 minutes. We uploaded it at the very end, even if it wasn't completed, and this is why we only got 46% of the project, because, it wasn't done. But the thing is, even if it was done, because of the bugs in the code, and probably the not optimized code, a lot of the projects were already past their deadline, so we didn't get score for 11% of the projects. Now, probably with more optimizations and more time, like an hour, maybe we could have gotten past the 1 million. But yeah, this is the score that we got, and honestly, I'm pretty proud of it. I think this was my best year for Hashcode. Last year, the question, I think, was much harder. It was about traffic and stuff like that, and I wasn't able to come up with an algorithm that, made sense. And I'm also glad that the team actually came up with similar algorithms, and we all had the same idea, we just coded it in a different way. But yeah, this is it. Now, Google is hosting other competitions, I think. There is one in early March, and maybe I'm gonna participate, maybe with the same team. Maybe if you guys are interested, I could live stream the process, but it might be a little bit boring because, most of the time we were just, brainstorming and we weren't talking, we were just like trying to focus on coding and stuff like that. But still, it was a really amazing experience. I had so much fun coding this, in the limited time that we had. And if you actually want to try and improve this code, you are totally free to do that. I'm actually going to post this code. It's already on GitHub, but I'm going to make this repository public. And I'm just going to leave this code to you guys. So you can go into this page right here. And I think even if you are not on a team, you are able to submit. But yeah, anyway, this is our team. Our awesome team. I'm fair coder, so let's go. But you should still be able to submit. And if you're not able to submit, you can just give me the code. I'm gonna try to submit it and I'm gonna tell you the score. But yeah, if you guys want to participate next year, I'm also gonna make sure to give you a community post to when that's coming and if any other competitions are coming up. I think you can also sign up to their newsletter to get more challenges. Okay, here you go. Yeah, the sample kickstart, the registrations are already open, so you can actually look into this. But there is also Code Jam, which are pretty similar competitions. There you go. The registration opens in March, so pretty soon. Anyway guys, I hope you really enjoyed this video. Thank you ever so much for watching till the very end. And this was the algorithm, this was our thought process, and hopefully you learned something new about how to approach a problem like this thanks to the video. Leave a like if you did and subscribe if you're new, and I'm gonna see you guys in the next piece of content. Bye bye!